this problem on stoichiometry, we're going to go through and find limiting reactant, excess reactant, theoretical yield, and percent yield of the problem. So here's the question. What is the percent yield of the calcium phosphate if 60.5 grams of phosphoric acid reacts with 72.4 grams of calcium hydroxide? These are going to form 81.3 grams of calcium phosphate salt in the experiment. So first thing, we're going to look at our reaction and we need to balance it. With the reaction balanced, we now need to look at the problem, find the numbers, and place them underneath the different compounds that they represent. For instance, the 60.5 grams of phosphoric acid, or the H3PO4, is where I need to put this number in our reaction. So we're going to put that 60.5 right here. Be sure to carry the units. For calcium hydroxide, we're going to have 72.4 grams. And then for the calcium phosphate, we do have 81.3 grams. Now the strange thing at this point in the problem is I don't have an X. Actually we do if we recognize that a product that is given a number is given in what's called the actual in our example. So this is the actual. The reason that we need this is because percent yield is going to equal the actual divided by our theoretical times 100%. So not only does the actual, is it given to us, it also tells us this is the component that we need to find that theoretical yield for. This will also be my X. It's going to be for grams because these two must match. Now that I know where the X is, I know that I'm solving for grams, we need to figure out which reactant is going to create less of my product. That way I can find what is going to be my limiting and excess reactant, as well as what's the theoretical yield. Using our map, we're going to be taking a look. We're starting with grams, and we're going to be going down to our mole using GFM. This map, being Stoic 2, uses what we call that bridge of the mole ratio. Using mole ratio, we'll be looking at those coefficients we found in our balance. And then we're going to be doing moles back up to our gram for the second map, again using GFM. So now, as we go through and we fill in these boxes, let's start with the first component first. We're going to take the 60.5 and put in our first box. Be sure to carry the unit as well as the compound. To cancel out grams of the acid, we're going to put it in the opposite spot, which is the bottom of the second box. We're also going to place that 1 mole on top. In order to fill in the rest of our box, for the gram, we're going to be using GFM. If you calculate the GFM, you would come up with 98.00 grams. Grams of the phosphoric acid have now canceled out, and I'm left with moles of phosphoric acid. With them on top, we're going to place them on the bottom so they cancel out. And this leads us in our map to the mole ratio. With the mole ratio, it means I need to have moles on top. And we're going to go to our X, which is the calcium phosphate. With mole ratio, you must use your coefficients. These are located in the reaction. So as we look at calcium phosphate, the coefficient is going to be 1. The phosphoric acid coefficient is 2. And that's how you fill in the numbers for our mole ratio. That now has us over to the last box which is where we go and we find the gram. Moles of phosphoric acid have canceled out, and I'm left with moles of the calcium phosphate. We're going to place those on the bottom. And we're going to have to find GFM for the grams that we're going to place on top. Since we're on the second map, notice we're back to the 1 mole. So we put our 1 mole in. The GFM for calcium phosphate is 310.18. On your calculator, remember that if it's on top, all of those numbers you're going to multiply, and then you're going to divide by anything on the bottom. When you go through the calculation, this will give you 95.7 grams. And that completes the first part of our problem. Now we need to test the second part of our reaction in looking at that calcium hydroxide, doing the same process to see how many grams of the salt it will form. So we're going to take a look at 72.4 grams. Place that in our first box. Don't forget to carry along the compound to make sure that everything matches up and cancels out correctly. We have grams of calcium hydroxide. We do not want them, so we put them in the opposite location on the next box. That will leave us with 1 mole on top of the calcium hydroxide. The GFM of calcium hydroxide is 74.10 grams. The gram now cancels out. Once we've gotten to mole, now we're going to use our mole ratio. So we're going to place we're going to place moles of calcium hydroxide on the bottom. For mole ratio, we're going to be using those coefficients. So if we go back to our reaction, notice it's not 1 that we're going to place there, but we're going to put a 3 because it's a 3 coefficient in our equation. On top, we do want to go to the salt, which is that calcium phosphate. And again, it still has 1 as its coefficient. Moles of calcium hydroxide cancel out. Our last box, since we're going to the same ending location, is the same as the one we've used before. The 310.18 grams of calcium phosphate on top. And we have the 1 mole of calcium phosphate on the bottom. And notice moles of calcium phosphate cancel out. When you're going through on your calculator, once again, everything on top you multiply, everything on the bottom you want to divide. The answer we come out with here is 101 grams. One quick comment. Notice we did not use the water because there is no numbers or any unknowns underneath it. It helped us balance, but we did not need it to answer the question beyond the balancing. Taking a look at our answers, we need to do some labeling. Starting with our 2 final results, they both represent calcium phosphate, but this one being the lesser amount, this is our theoretical yield. Now, when we have our theoretical yield, going to the beginning to see where it came from, that means that this H3PO4, the phosphoric acid, that is our limiting reactant. If the phosphoric acid is the limiting reactant, calcium hydroxide is going to be the excess reactant. Once you have those 3 big pieces labeled, our theoretical, our limiting reactant, and the excess reactant, now we can go through and do our last step, which is the percent yield. Remember, percent yield equals your actual divided by the theoretical, and that is times 100%. So, going back to the beginning, our actual is 81.3 grams. We divide it by the 95.7 grams times 100%. The goal of this answer needs to be between 0 and 100% to make sure that it fits within the law of conservation of mass, that we've neither gained nor destroyed any mass. The answer here comes out to be 84.95%. And that is our percent yield. And this is the end of a Stoich 2 question.